I'd like you all to imagine an alternate world where art was taught differently. Instead of mixing colors, students are forced to rote memorize the color wheel. Instead of drawing something unique, students paint by numbers, repeating what has already been done by someone else. Now, the artists might scoff and say, that's not teaching art. They haven't made anything creative at all. But the thing is, that is exactly how I feel about the way math is taught today. Unoriginal. Now, you might be thinking, why are you comparing art to math? Math is logical, it's grounded, there's no space for creativity. Well, let me take a step back and explain what math is truly about. Behind all of the complicated, the technical jargon, mathematics is about finding patterns to solve beautiful problems. To illustrate this, I'd like to go back to everyone's biggest nightmare, primary 4 mathematics class. In school, you might be asked, what's the area of this trapezium? Well, you just use the formula a plus b divided by 2 times h, substitute everything in, get 16, right? But where does this formula come from? Let's look at this trapezium again. We can draw 2 lines, splitting this into 2 right triangles and a rectangle. We can then stick these right triangles to form a bigger triangle and a rectangle. We know the area of each, so we add them up together to get the area of our original trapezium, 16. But what's interesting is that this process also applies to similarly shaped trapeziums. That's to say, if we just got rid of these side lengths, this argument would also apply for infinitely many different trapeziums. We've proved the area for many different trapeziums without even using words. All we did was just look at the trapezium in a creative way. That's beautiful, and that's what maths should be like. But as we return to reality, we're reminded of the way maths education works today. Exam boards put the formula for the area of the trapezium on the specification, and teachers are forced to do the most effective thing to improve students' grades. They pile pages upon pages upon pages of worksheets about the formula for the area of a trapezium until the formula and its applications in contrived word problems are seared into our brains. The unfortunate reality today is that exam boards focus too much on the applications of maths while forgetting why people do maths in the first place. And while it's important for students to have a basic grasp on the way maths works, this kind of exam-based drilling only causes students to think that maths is the study of doing things repetitively, without rhyme or reason. They just don't see the beauty or creativity of maths because they've never been exposed to it. And so people think that maths exists solely for its applications, when it's perhaps the opposite. You might be wondering how we could solve this educational dilemma. Now, I know pedagogical experts, and I still believe that students should have the basic numeracy and computational skills. But schools and exam boards must understand that applications of maths must come hand in hand with teaching creative problem solving. So now I'd like to present some examples of maths education done right. My first example is the IB curriculum. Now, maths is a process that can take months to years, and no exam can fully replicate that. While IB is mostly exam-based, it's still got something special called the internal assessment, where students conduct their own independent research into mathematics. That encourages students to delve deeper into a part of mathematics that they're passionate about and better understand the proofs that lie within, or come up with an original problem that interests them and come up with a creative way to solve it. Another example are mathematical Olympiads. In these competitions, students write proofs to problems from topics ranging from algebra to geometry. By using these kinds of secondary school topics, the questions are quite accessible. Accessible doesn't mean easy. Take, for example, the International Mathematical Olympiad, where students are given 9 hours to solve 6 problems. One of them looks like this. It looks easy, right? I can see some of you starting to yawn. This solution is hard to even parse, let alone come up with within 90 minutes. And Most people trying to do this problem would hit a brick wall and fail and hate maths. So, when I say do mathematical Olympiad problems, I mean things more like this. This is a lot better problem, even though it's a challenge, because it explains difficult notation, and it's got two subparts, where the solution to the first subparts hints at the solution to the other one. And as long as you select the problems appropriately, these kinds of problems can help stretch and challenge students' understanding of mathematics while allowing them to experience the creative problem-solving process. We can do away with the competitive and time-pressured nature of Olympiads, but we can better incorporate these kinds of problems in the school curriculum. Finally, I'd like to mention the plethora of blog posts and videos that are freely available on the internet that seek to show mathematics beyond the repetition. I deeply admire creators such as Free Blue One Brown, Mathologer, Frail Homer, and VCubingX, and more, for their ability to show mathematics in thought-provoking and interesting ways. Of course, I'd like to thank the wonderful teachers who don't just pile worksheets, but rather ensure that their students understand and enjoy mathematics. These teachers should be given more recognition for their work. In conclusion, I hope you all see maths in a slightly different light and can take on board some of those suggestions I've made. Maybe you can look at a rule that I've always assumed to be true, but consider why and think about why it's true. Or try a mathematical Olympiad problem. Or take a look at one of those videos from those creators I mentioned. Now, maybe you won't necessarily enjoy it. That's okay. Not everyone paints, does acting, or does fashion design as a hobby. But maybe you'll enjoy it, and you'll understand and appreciate the beauty in mathematics.